Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. So in this example, I want you to find the nth term, the 10th term, and the 24th term of the sequence you can see in green there. Okay, we've got 2, 8, 14, 20, and so on forever. Okay, now in red, this is a review of the previous video. We talked about trying to find the 0 term. And the 0 term is the term before the 2. Okay, so let's maybe start with that. Alright, so, well actually we're going to have to start with the common difference. That will help us find the 0 term. What's happening? Well, it looks like we're adding 6 there, and 6 there, and 6 there. And it's very consistent from what we can see so far because it is an arithmetic sequence. That's what it means. We're either adding or subtracting the same number each time. Now I could keep going and manually just keep adding 6 until I can answer my questions over here on the left, but that's inefficient, and we also want you to know how to do the algebraic term, which is the nth term. So the common difference then is going to be 6, okay, and it's going to be a positive 6. We're adding 6 each time. Alright, now again the question is, what's the 0 term? So we want to find out before the 2, what number did we start with? Well, if you're going to subtract 6 from 2, what is that going to be? That's right, -4. Okay, so the 0 term is -4. Okay, so we start with -4, and we're going to start adding 6 repeatedly. Okay, the difference, the idea here with the n is because that's the number of the term. Alright, now let's take a look. If n is 0, and we put this in our formula here, that would be 6 times 0. Alright, let's do the math and figure that out. What is the 0 term? Well, 6 times 0 is 0, and -4 plus 0 is -4. Okay? And we already talked about how we'd have to start with a -4 even before we get to the 2. Alright, now what if we want to know the first term? Now up here in green it says 2, but let's double check that. So we'd have -4 plus the common difference of 6 times 1, because we want to know the first term. 6 times 1 is 6. 6 plus a -4 would be 2. Okay? So we're just kind of testing our algebraic term to make sure. Let's go ahead and answer the second question. What's the 10th term? Well, we start with the -4 0 term, and we're going to add to it multiples of 6. 10 multiples of 6, because it's the 10th term. So that'd be 60. Take away 4, 56. Alright, so over here, the answer would be 56. Now let's go ahead and fill in number 1 here. Usually, if the 0 term is negative, we put it at the end. It just is kind of a basically proper form. So just to kind of clean it up here, that would be 6n minus 4, and 56 is the 10th term. And let's finish this up. Let's find the 24th term. -4 plus 6 times 24. Alright, let's do a quick multiplication problem here. 24 times 6. 24. Carry the 2. 12 plus 2 is 14. Alright, 144. Alright, now let's kind of take this to some graph paper. On this graph paper I have the blue dots representing the numbers of another arithmetic sequence. Okay, so the first thing we need to do is record what those numbers are. Alright, it looks like if this is the number of term, okay, these are my n numbers, then this number represents the number of the sequence, what actual number shows up. Okay, so if we're going in this direction, this is the x-axis, and I go over one location there. If n is 1, let's make a little table here. Then it looks like we go up 1 there. So the first number of the sequence is 1. All right, so we're going to start with 1. All right, now if we go over 2 in the n direction, we're going to go 1, 2, 3, 4, 5. So if n is 2, the sequence number is 5. All right, so far we have a 1 and a 5. And we just keep recording that as we go. On the third n here, the third term, it's 1, 2, 3, 4, 5, 6, 7, 8. So when n is 3, the term of the sequence is 8. All right, now we do have a missing dot right there. Okay, we can easily figure it out, but I'm going to just leave this blank for now. So when n is 4, we have a mystery number right now. Now on our graph, of course, we do have the next dot. So if n is 5, going over this direction, we actually go up how far? 2, 4, 6, 8. Whoops, I need to count correctly here. 2, 4, 6, 8. I see what I did. It's going to have to be a 9. I better add correctly here. All right, so we've got 9 right there. 10, 12, 14, 16, 17. All right. So we have got a number sequence that goes forever until we run out of graph paper, of course. And as you saw in the other part of the video, what we have to do is figure out the common difference and the zero term. And that's the key to finding our algebra representation here. Okay, so the common difference is 4 each time, isn't it? So I'm going to skip a number there, but obviously 9 plus 4 would be 13. So there'd be a 13 in that spot right there. And then if I add 4 more, that would be 17. So my common difference is 4. Okay, I'm going to multiply that by the number of the term we're talking about, so it's 4n. Now the other question is, what is the zero term? Now if I'm going to add 4 each time, then if I go backwards, I'm going to subtract 4. So what's 1 take away 4? Negative 3. So negative 3 is my zero term. All right, so have a zero term of negative 3, a common difference of 4 multiplied by whatever term we're talking about. All right, if we put it in a little simpler format here, since 3 is negative, let's put it at the end. So the nth term is represented by 4n minus 3. All right, what's the 10th term? Let's substitute the 10 in there in place of n. Okay, so 4 times 10, which of course is 40, take away 3, 37. Now I could have found it by just extending my number sequence forever and kept adding 4, 4, 4, 4, 4. But of course we can jump right to it if we know the algebraic expression for it. The 24th term is 4 times 24, which is 96. Take a 3 away, 93. Okay, much quicker, much easier using the algebraic expression. All right, good job. Thanks for watching. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard,